Good morning. Let's go ahead and start section 3.7. Now this is actually the last lesson pretty much in this chapter. You're going to have another part of a lesson to do with it, but this will be all you do until you take your quiz, and then we'll take our quiz today or tomorrow. All right, now we've practiced finding the value of unknowns. It's time to apply the skills that you've learned to another setting. As we do, we'll see once again that math truly is a useful tool. Altitude is a concept that we use all the time, but we don't usually use this word. When we say a building's 300 feet tall, we're really saying that its altitude or height relative to the ground is 300 feet. Altitude is simply the height of a thing above a referenced level, especially above sea level or above the Earth's surface, also called elevation. In other words, altitude helps us describe the height of something in relation to a specific reference level. In the case of a building, we view the ground as our reference level. So this would be like our reference. This would be like the ground. Okay. Mathematically, that means we think of the ground as having an altitude or height of 0 feet, meters, or whatever unit we're using to measure. We can then view altitudes or heights above ground level as positive, and then those below, like a basement or underground parking, as negative. Okay. When finding the area of a triangle, for example, you use the height or altitude of the triangle. Notice that in this case, the height is relative to the base of the triangle. The base is the fixed reference level that we've used to find the height or the altitude of the triangle. Now I want you to take a look at this picture that's in here. So this would be like if you're looking into the ocean, you cut it in half and you're just looking at it. Sea level would be level with the sea. Your positive altitude would be that above it, and your negative level altitudes would be the levels below. Sea level is a common reference level. So if you hear that a town has an altitude of 6,000 feet, that means its ground level is 6,000 feet above sea level. They don't always say above sea level, but that's what it means. That's how it's referenced. Okay, I hope you're seeing that altitude depends on or changes based on what we use as our reference level. If measured from sea level, a ski lift station might have an altitude of 9,000 feet. However, if we want to look at the altitude of the top of the mountain relative to that ski lift station, we could look at the same ski lift station as our reference level, viewing its altitude as 0 feet. So it depends on what you're using as your reference point. All right. Now, to avoid confusion in problems, we'll use the word altitude to refer strictly to altitude in relation to sea level, and then height to refer to altitude in relation to some other fixed reference level. So don't let the term altitude confuse you. We're using it simply to refer to height relative to sea level. All right, so let's use unknowns to explore altitude. Now, in real life, we often need to look at problems related to altitude or height. At what rate does a plane change altitude as it takes off? At what rate do dolphins, submarines, and divers descend into the ocean? All this is changing altitude. At what rate does an elevator change height as it travels between floors? When changing altitude, the altitude or the height you'll end up at depends on the rate at which you're changing altitude or height, the time over which you change it, and the altitude at which you started. Could describe this using this formula. Altitude or height formula, A for altitude or height, equals rate of change in altitude or height, that's your rate of change, times time, plus initial altitude or height. Now that little subscript I right there indicates that the A stands for the initial altitude or height. The rate in the formula represents the average rate of change in altitude or height. Now, as we've been doing with the other formulas, you can use that formula coupled with what we know about unknowns to solve real-life problems. Now, I do want y'all to be able to use your formulas on your quizzes and stuff. So if y'all want to write them down and put them on the wall or whatever you want to do. It doesn't matter to me. I don't care if you use them. I don't mind that you don't have them memorized. So let's look at this example. What would be the rate of change in altitude of a helicopter that takes off from sea level and reaches an altitude of 100 feet in 5 seconds? So we're taking a look at the values that we know and then what we need to find. We've been told the time, the altitude, and the initial altitude. We know that it's 0 feet since we were told we're starting at sea level. We need to find the rate of change in altitude. Okay, so A is 100 feet, that's your altitude. We don't know the rate, that's what we need to find. The time was given as 5 seconds, and the original altitude was 0 feet. We know that because it says it's taking off from sea level. So it's giving us a place where it's taking off from, so that's 0. So you can substitute all those numbers in for this formula. 100 feet equals rate, which is what we don't know, times the time, which is 5 seconds, plus the initial altitude, which was 0 feet. Now, since adding 0 doesn't change the value, remember the identity property of addition? You can ignore the addition of 0. In fact, you may see problems with an initial altitude of 0 written this way from the beginning. Now, so they went ahead and got rid of that because it's not going to change anything anyway. So we're just left with this. Okay? Now all you need to do is find the unknown. So you're going to divide both sides by 5, do all your calculations, and you're left with 20 feet per second is the rate. Okay? Now let's look at the negative unknowns. Up until now, all the problems involving unknowns have only had positive numbers. But as we work with altitude or height, we end up dealing with negative numbers too. So we're going to look at another helicopter example. This time, though, instead of the helicopter ascending to 100 feet from sea level, we're going to take a look at the helicopter that has to descend into a valley 100 feet below sea level. So look at your next page here. Suppose a helicopter is flying at an altitude of 0 feet sea level across a valley that's 100 feet below sea level. If it descends into the valley, at what rate would the helicopter have to change altitude in order to descend to the bottom, an altitude of negative 100 feet, in 5 seconds? So we have to look at what our formula is and what numbers were given, and then plug them in. The altitude is negative 100 feet. The rate we don't know, that's what it's wanting us to find, times 5 seconds plus the 0 feet, which we were told. So that simplifies down. You'll get rid of this here because it's not going to change anything, so you're left with this. Now all you need to do is to get the unknown by itself. You can do this by dividing both sides by 5, as you see that. Again, since the fraction sign represents division, you just use it to represent division. That's why we just do it this way. Now, you're left with negative 20 feet per second. So that this time the rate R ended up being a negative number. We found its value the same way we have been, though, by separating on the side by itself. Don't let negative numbers and problems confuse you. Just as you can add, subtract, multiply, and divide the same positive number to both sides of an equation without changing the equality of the expressions, you can do the same thing with negative numbers. You just need to be sure to apply those rules for adding, subtracting, multiplying, dividing negative numbers. We covered that way back in Chapter 2, I think in Book 1. No, it was Book 2. Anyway, and I think you should have a chart, too, that kind of shows you, helps you keep in mind what we do here when we do the negative and positives. Okay, hope you had fun exploring altitude. The problems in your workbook will help you continue to use math to understand the world around us, so you'll be equipped to use the skills you're learning to serve the Lord in different settings. Since real-life settings often include negative numbers, you'll notice that many problems in your workbook will too. Again, don't let the negatives confuse you. The principles you've learned about how to find the value of an unknown still apply. Simply combine them with what you know about negative numbers. Okay, with that being said then, let us look at our worksheet. 3.7. Now it is front and back. It's a full page, 2 full pages. So I'm going to kind of skip through here and help you with a few of these. So On number 1, you've got A, B, C, and D. Finding your unknowns, solve each equation for the unknown. That is to isolate the unknown on a side by itself so as to find its value. So show what you added, subtracted, or whatever to both sides. Basically show your work. Okay, so I think A is pretty easy. B should be easy. C, okay, C should be easy. Let me go ahead and help you with D on this. Okay. On D, we have x over 6, or x divided by 6, equals negative 36. Now, this is an example meaning. What was the final altitude after 6 minutes if the rate at which we changed altitude was negative 36 feet per minute and we started at sea level? Okay, so basically what we're going to do here is, let me make sure I'm on the right one over here. Yeah, okay, so what we're going to do is we're going to take we want to get x by itself. So what is the opposite of division? Multiplication. So we're going to divide both sides. Well, it's easier if you just rewrite it. Equals negative 36. Okay. So basically we're going to multiply both sides by 6. Okay. This cancels this out. So we're left with x by itself. So then x is going to equal, now you're going to be multiplying a negative and a positive. So your answer, you already know your answer will be a negative. So you're just going to multiply 36 times 6 and that'll be your answer. Okay, so let's move on then to number 2. Now, if you'd rather pause it and work on those at the top, that's fine, or we'll just kind of go through this. I'm not going to help you with everything. Just want to help you with a few of them. All right, so I'm going to help you with, let's see, we're going to be using the formula. Actually, I have to erase this because if I don't, then when I go to print it out, everything will be there and it'll probably confuse someone, probably me. Okay. Let's go back to right here. So we're going to be using that formula that's in your book that we were just using, and that is altitude equals R rate times time, and then plus initial altitude. Okay, so that's our formula. So, so basically you're going to take these and you're going to do what we did on the examples. You're going to just put in the numbers that you've got and then work the problem. So on this one, if a helicopter starting at sea level, that's 0. That's the original altitude. So we'll just put that there. Let's just go ahead and put that in there as we get that. If it ascends, it's going up, to an altitude of 12,000 feet. That's our altitude. Make sure we put our unit. In 15 minutes, that's our time. It's wanting us to find the rate. At what rate? So we're going to find rate, and then our time was 15 minutes. Okay, so we're left with our formula. Now that we've plugged in our numbers, we're left with 12,000 feet equals rate times 15 plus 0. Well, we know that the plus 0 is not going to do anything, so we're just left with this. Okay, so to get R by itself, we divide both sides by 15. That cancels this out, so you're left with R by itself. So your answer, I'm not going to do the answer, but your answer will be what this is. 12,000 feet divided by 15. And that's going to be what your answer would be. Now, it's going to be, let me look back here, see if it tells us this. Okay. So always pay attention to your units, because if you go ahead and get your answer and it's just, whatever your answer is, you have to put a unit. Okay, what's 100 what? Or I'm not saying that's the answer, but whatever the answer is, okay, what are you talking? Are you talking about pecans, or what are you talking about? So we're going to have to figure out what we're talking about. So with that being said, you'll go back here. This was 15 minutes. See, I didn't put my stuff there. Okay, these were minutes, so we got rid of those. Okay, so we're left with whatever this is, feet per minute. So whatever your answer is, feet per minute. Okay, putting that those units is very important, so make sure you do that. Okay, all right, I'm going to let you finish that one and do that one, do the next one. Now on the back, this one, and this one, you will be working with negative numbers, but the only thing you have to remember, everything works exactly the same. The only thing you have to remember are those rules about adding, subtracting, multiplying, dividing negative numbers. If I have 2 of these, then what's my answer? If I have 1 of these and 1 of these, what's my answer? And you should have a little chart that you had, or some kind of notes or something that you printed out or that you wrote down to help remind you of those. So that's the only thing you have to do. It's the only difference, is just remembering if your answer is going to be negative or positive. Okay, so I'm not going to walk through those with you. Now on this one, this is easy. You'll just write what H represents. Now on number 4, make sure that whenever it says to simplify, make sure that means you actually do your answer. The reason it says simplify is because sometimes you have to, you've got something to do before you can actually get your answer. So anyway, but on these, basically you're just going to get your answer. So just work these problems, see if you can find the answers. Now, I'm assuming that this problem here, number 5, might possibly present a problem, so to speak. No pun intended. Well, actually, yeah, that pun was intended. I'm going to have to erase this. I'm sorry. I have to do this now before I forget, because I will forget. All right, let's do our corn problem. A field of corn is planted in hills 44 inches apart each way. If a square field has an area of 1 acre, which is 6,272,640 square inches, how many hills could be planted in the square field? Hint: if each hill takes 44 inches each way, then it takes up a circle with a 44-inch radius. However, we won't be able to use some space in between each of those circles, so in reality it will take up the area of a square that can contain a circle with a 44-inch radius. So find the area of the square shown, which would be this, the area of the square, and then divide the total square inches in an acre by it. Okay, so let me get my stuff out here so that I'm going to know how to work this with you, because when I read this, I was a little bit like, what? I was a little bit confused. Okay, so find the area of the square first, because we've got a field of corn that was planted in hills that are 44 inches apart each way. If a square field has an area of 1 acre, which is this many square inches, how many hills could be planted in the square field? Okay, so each hill takes 44 inches each way, and it takes up a circle with a radius of this. So basically that's what it's telling you. This is what it's taking up. This is our square field, okay? But where they're planting it takes up this much space. So find the area of the square. Well, do you remember how to find the area of the square? Well, actually, I don't think that would be what we do first. Dimensions of each side of the square. Okay, in my book, let me get my answer key out to make sure I'm telling you right way. Okay, 5. Let me find my number. Where did I go? 3, 7, number 5. Okay. It's telling us the dimensions of each side of the square, and then it's telling us 2 times 44, and that inches. Therefore, that's going to be 88 inches. Okay, that would be our, I think that's what that's talking about. Now the area for each hill, the area for the hill is going to be, let's see, 88. I'm not sure I'm quite following this. I'm looking at my teacher book, and I thought I knew what to do before I looked at my teacher book, and now this got me confused. I'm writing down the answer here. Maybe you can make some sense of it, because it's not making any sense to me. Okay, this is what it's showing me. I thought I knew what to do. Okay. A field of corn is planted in hills 44 inches apart each way. If a square field has an area of 1 acre, how many hills could be planted in the square field? If each hill takes 44 inches each way, then it takes up a circle with a 44-inch radius. However, we won't be able to use some space in between those circles, so in reality it'll take up the area of a square that can contain a circle with a 44-inch radius. So find the area of the square shown and then divide the total square inches in an acre by. Okay. So this is going to equal, when we do all of our calculations, if you were to multiply 88 times 88, you're going to get 7,744. I knew I didn't need that teacher book. Teacher book got me confused. And that's going to be square inches. That is the area of the circle. I'm sorry, the area of the square. Now, because we have, see, 44, 2, yeah, because the area of the square we would do, because it's 44, 44. Okay, if each hill takes in 44 inches each way, so 44 and 44, so that'd be 88, and then multiply, I'm sorry, yeah, and then 88 times 88 gives us 7,744 square inches. Okay, then what you're going to do is you're going to figure out the hills per acre. So you're going to take this number here, which is the square inches, and you're going to divide this number by this number. So basically it'll be this number right here on top of that one, because you're going to divide it. Both of those then are square inches. Okay, and then once you do your division, and of course you can use a calculator on this one, once you do your division, you'll get how many hills it is. That one was a hard problem. It was hard for me to understand by reading it and then looking at the teacher book, because to me those didn't go quite together, but that's what they did. Let me read it one more time. A field of corn is planted in hills 44 inches apart each way. Each way. That's where they have 2. They get 88. Okay. And then they say they're going to take So that means it's planted in two different directions. The radius is 44 inches. It's planted in two different directions. So that's where they get the 88 inches as being the side of the square. And then they're going to multiply to get the area of the square 88 times 88 to get the area of the square, which is this. And then what they do is they're going to divide the total square inches an acre by this. And then that's going to tell you how many how many hills could be planted in that. Yes, that's very hard. Your answer is 810. 810 hills. Yeah, I'm a little bit confused by that one still. All right, so make sure you like circle it or something and put like, Miss Shelley, you helped me with this, or actually, Miss Shelley, you didn't know what you were doing, or something like that in there. So I'll remember not to put any grades or anything on that one, which I'm not going to grade this page anyway. So, okay then, on B. For the field described in 5A, this field that I don't quite get, what should the yield in bushels be if the average hill produces 3 ears of a size such that make that 120? Let me reread that. For the field described in 5A, what should the yield in bushels be if the average hill produces 3 ears of a size such that 120 make a bushel? All right, so we know that 810 times the 3, because it's 3 ears, okay, and then once you get that, you're going to come up with 2,430 ears of corn. Okay, if you take the hills and it produces 3 ears of a size that make 120 a bushel, then you're going to take the this number and divide it by 120, because 120 makes a bushel. And then this is ears. We have to make sure we get our units right. This is ears, and then this would be bushels. Okay, that makes more sense to me. Okay, so I'm going to let you do the calculations on that because you get to use your calculator. I could put the answer there, but I'm not. But nonetheless, this is not part of a grade because this is confusing to me. Okay, so your assignment is to finish these 2 pages, and then you need to read section 3.8, which is basically the chapter review. There's nothing to do, just read. And you're going to be reading about a mathematician that lived many, many years ago. And once you're finished with all that, either today or tomorrow, you can take quiz 2. But there's no video or anything for quiz 2. Quiz 2, I think, will be worth like 11 points. If you need help, please let me know. I'm just going to hope that there's not a field of corn question on there, okay? All right, that's all for today.
Yeah!